As you know, when the exception happens, RISC-V heart will update the several control status register. The first one is supervisor exception name from counter register, and another one is supervisor status, and another one is stval, and last one is supervisor calls register. But as you can see, the value of these control status registers can be printed in the kernel log. Here is the signature when the exception occurs in RISC-V based device. So this signature indicates the value of the supervisor exception and from counter register, and this signature, this value is about supervisor status register, and this signature is the value of stval register. And here is the signature that is about supervisor calls register. Among this signature, the most important signature we need to refer to is the value of the two CSR register. First one is supervisor exception from counter register, and another one is the value of stval. Because this register lets you know instruction of the exception that cause this kind of some memory fault or illegal instruction or some memory overload. Together with this register, another signature we need to observe is the value of stval register, because this register lets you know the faulty address. So usually when the data overload or some sort of the page fault occurs due to invalid memory access, that the faulty address during invalid memory access can be identified in this register. So these two individual control status registers are important for debugging purpose. So at this moment, let's review the RISC-V reference manual that describes this register. So sepc register means the supervisor exception from counter register. As the name of this register implies, this S letter means the supervisor mode. So this register is updated when the exception is taken to the supervisor mode, not the machine mode. So the important point is this register is written with the virtual address of the instruction that was interrupted or encountered the exception. In other words, when the RISC-V core generate exception, the address of instruction that caused the exception will be written to this register. This is important, the point to remember. Now let's look at the register layout of stval. But in the case of the memory register layout, there's no bit the assignment map register layout in this case, because when the RISC-V core generate the exception or interrupt, this register will contain the faulty address. So this RISC-V reference manual describes that this register will contain the virtual address of the portion of the access that caused the fault. So if we explain this symbol content in more detailed way, so faulty address during the execution of instruction will be written to the control status register. Once we review the RISC-V reference manual that describes those two registers, we're not sure whether which address is actually written to those two registers. For better understanding, we're going to review the case study for each exception, depending on the type of exception from the memory overload to system call. So this will be explored in the later lecture.